Actually, wait, let me check. Okay, I'll copy.
Okay. And also, you can always see a recording of this. Okay, so if you don't get it copied, you can always go back and look, and you'll see all of this material presented from beginning to end.
Could we do number 6?
Sure. Again, very complicated looking, but not hard to do.
Yeah.
Remember, let's get rid of parentheses. So let's tackle the top. There's a z to the 1/4 or the negative 1/4 that I'm just going to leave like that for a moment because my initial goal is to get rid of parentheses. Now, to remove these parentheses, what do I have to do?
Multiply the exponents in.
Okay, so what's y going to be?
On the bottom or top?
Top. Top only. We're going to do this one step at a time.
Y would be y to the negative 1/2.
Good.
And x would be negative 1.
Good. Now let's remove the parentheses in the bottom. What do you get?
You have x to the 4 and 10 to the 4th, which can be simplified to 5 to the 2nd.
Multiply 2 times 5/4. Get 10/4, which simplifies to 5/2.
Yeah, that's what I said.
Okay. Ah, that's what you meant. Okay. All right. Now we can do one of two things. We can just take each variable we come to and put it on the right side of the fraction bar, or we can operate. In other words, I've got a y in the numerator and I got a y in the denominator. How would I divide those y's?
Would you just, would you add them?
Subtract. Remember, when you're dividing, you got to have subtraction. Subtraction goes with division. Addition goes with multiplication.
So you, when they're on opposite sides, you just subtract them.
That's division, yes. When they're on opposite sides of that fraction bar, I'm dividing one term by another. I'm going to subtract. Now, there is perhaps an easier way to look at it. It's not that easy to subtract exponents when one of them's in the negative number. So the other way we could do this is we could take every variable that's in the numerator and move it to the denominator, right?
Yeah.
Let's just do that. That makes the whole thing a little more understandable. There's the z to the 1/4. There's another y to the 1/2.
Put it like over 1 or something.
What's that?
Don't you have to put it like
No.
under 1?
Nope. Nope. When you have a fraction, if you have a negative exponent on that variable, just move that variable to the other side and make that exponent positive, just like I just did.
Well, now that there's none on that, you just get rid of that.
Well, the numerator becomes 1, yes. Okay? Because there's nothing left in the numerator. And I don't see any negative exponents down here. So I'm not going to end up with any negative exponents in the bottom. I'm going to end up with a 1 in the top. Only because when I move this z to the minus 1/4 down below, yeah, I'm left with a 1. So I end up with 1 times 1 times 1. So 1 is the only thing left in the numerator. Now, how many z's do I have in the bottom?
1/4.
That's it. How many x's do I have? Well, I shouldn't really say that. I mean, what's x to the 4th times x to the 1? That's x to the 5th. How about my y's?
Y would be 6/2 or 3.
Yeah. And notice how much easier it was to add these two exponents than it would have been to take -1/2 minus 5/2. So there was a clear advantage in moving this down below merely to change its exponent to a positive number, because positive numbers are much easier to work with. There's your answer. Notice I have no need to put this into a radical. I could write that fourth root of z, but why? The fractional exponent is just as valid as the radical sign.
Okay.
And they didn't start with any radical signs. Perhaps you could make an argument back in number 2 that, well, they gave us the problem with a radical sign, let's give them the answer back with a radical sign. Some people might say that. Okay? But we're not going to. Unless your teacher specifically requests it. Notice the instructions for 3, 4, 5, and 6. Your answer should contain only positive exponents. Your variables may or may not be fractions. Okay, well, here's our answer, and it contains only positive exponents. Therefore, all 3 of my variables have to be below, have to be in the denominator, because if any of them were in the numerator, they'd have negative exponents.
Yeah.
Okay?
Could we do
5, notice that 5 is the same thing. What's the first step on 5 going to be?
distribute?
No, get rid of the parentheses. Always get rid of parentheses. Pretty much when you're simplifying an expression or when you're solving an equation, one of the key first steps is get rid of your parentheses. Not 100% of the time, but 95% of the time. Okay? So the first step I'm going to do on 5 is I'm going to take this outside exponent of minus 5/3, and I'm going to multiply every single thing that it is covering. Well, it's being applied to everything in the parentheses. So my answer is going to start out m to the minus 5/3, because that m was to the 1, right?
Yeah.
And then p to the positive 20/9, multiplying that minus 4/3 times minus 5/3. And then m, I don't want to do too many steps at one here. So that's minus 25/12. Make sure you see where I'm getting this from.
Yep.
And then p to the positive 15/6. And I'll leave it like that for a moment. I don't need to reduce it at this stage. And then what I have in the denominator is what?
You have like 6. You can just multiply that would be negative 20/3.
20/9. Remember, when you're multiplying fractions, you got to multiply the numerators and the denominators.
Yeah. Usually I do it on my calculator. So
well, this is actually better to not do on your calculator, because when you do it on your calculator, you're going to get a decimal answer usually.
Well, I always just convert it in the math.
Okay, that's fine. That's fine. But these aren't hard to do without a calculator. You're multiplying 5 times 4, and you're multiplying 3 times 3. It's almost better to do it without a calculator, because it reinforces how you do it. If you are so dependent on your calculator that you occasionally forget how you do this, that's a bad thing. Okay. Now, I've removed the parentheses. I no longer have any outside exponents. So now I can go about combining my m's, combining my p's, and then putting them on the correct side of the fraction bar. So let's take m first. Multiply that m times that m, which is the only thing I can do. That you can only multiply same bases. What do you get?
You would get 125 over 36.
Yeah, positive or negative?
Positive.
No, you're adding these
Oh,
exponents.
you're adding them?
Uh-huh.
Well, I multiply.
I'm sorry. Your first answer wasn't right. I lost my train of thought for a moment. Yeah, if I'm multiplying down here, I'm going to multiply 5m to the minus 5/3 times m to the minus 25/12. Well, I have to find a common denominator, which is 12. So this becomes 20/12. Now add those two exponents, and I get an m that is minus 45 over 12. And that takes care of that m and that m.
Yeah.
Now I'm going to furthermore put it in it's the only m left, so let's put it where it belongs, down below with a positive exponent.
Yeah.
And now I'm done with the m's. Okay? I'll leave them here in case you're copying. So now let's handle the p's. You're going to add those exponents. So what is, and that's fine if you want to do this on a calculator.
Okay.
Because they've given you so much arithmetic here that this becomes a test of arithmetic, not so much a test of your knowledge of exponents. Both, but they're throwing in so much arithmetic that it's slowing us down. And it's going to slow you down when you take a test. In other words, the hard part isn't the exponents. The hard part is all of the arithmetic, multiplying these exponents together or adding them or subtracting them. What's 29ths plus 15/6? Let's see. That's
85/18.
Yeah, 85/18. So I'm going to cross out that p, cross out that p, and I'm going to put a p in the numerator. What was it? 85/18?
Yeah.
Okay, so now I got nothing in the numerator except p to the 85/18. I have this m in the denominator, and I have this q that's got the negative exponent. So let's put that q in the numerator.
Okay.
So that becomes q to the 20 over 9. Now I'll erase it from the denominator. And there's your answer. Is we have q to the 29ths. Can't simplify that, times p to the 85/18. Don't think I can simplify that. None of these numbers have been very simplifiable, so I'm assuming that is not either. All over m to the 45/12. Now, I can simplify m to the 45/12. What does that simplify to? You can do it on your calculator.
15/4.
Yeah. The one advantage of doing it on your calculator is if you're quick, you can speed up the time it takes you to do all this arithmetic. There's our answer. We've got nothing but positive exponents, and they're in the right side of the fraction bar, and they've all been combined. In other words, all the q's have been combined, all the p's have been combined, all the m's have been combined.
So Could we do like 7 and 13?
Uh-huh. That must be on the next page. Open it up. All right, composite function is what this page is. Okay, let me do this. Is that an x cubed plus 3?
Yeah.
And g of x is a different function, 3x plus 5. So let me ask you, what is f of 2? If I said to you, what is f of 2?
Doesn't that mean you put 2 in place for x?
Yes. Everywhere you see x, you substitute whatever's in the parentheses. It doesn't matter if it's a 2. It could be something like f of x plus 1 over x minus 1. Then you take that and you substitute it for x in the function. So
Yeah.
that's what a number in the parentheses means. Okay? So
Yeah.
when they say f of g of x, what they're really asking for is this. That's what f of g of x means. Inside the parentheses goes g of x. Well, what is g of x? It's 3x plus 5, right?
Yeah.
So now I'm going to write it like this. That's what they want. Now, how do I answer that question?
You put 3x plus 5 in place of every x in the f of x.
There's your answer. Now, whether she wants you to fully expand that or not, I kind of doubt, but maybe. Only you know. In other words, that's the answer, but notice that I could cube that. A lot of math, because the first time I square it, I got 3 terms, and then I got to multiply 3 terms times 2 terms, but I will be able to eventually add that 3 to it. So to fully simplify this, we really do need to expand it. Let's make sure you know how to do that. So what that means is 3x plus 5 times 3x plus 5 times 3x plus 5. And the only reason I'm expanding it is because when I get done, I'm going to be able to take that 3 and add it to the last number that I have. Okay? Multiply. I'm going to do the multiplication just to speed us up. What time do you have to go, Sam? You got to go to class?
Yeah, in like 15 minutes.
Okay. Let me do the multiplication for you here. Make sure you follow what I'm doing, though. So that's 9x squared plus 15x plus another 15x. That's 30x plus 25. That's the result of the first two being multiplied together.
Couldn't f... So for number 7, it says find f times g.
It's not times. It's f of. That little circle that you're seeing is not a dot. That is not, no. This is typical f of g notification, but now that I look at it, that dot, I suppose you could interpret, no, I don't think that that's multiplication, but I might be wrong. Maybe, because look at number 10. You see that little O?
Yeah.
That's g of f of x. That's not multiplication. That's written this way, and then you'd write it this way, and then you'd figure out what it is. Whereas this first one, number 7, now that I've looked at some of the others, I do think that is multiplication. So all we have to do is multiply those two functions together. I apologize. I was misreading it. So you're multiplying x cubed plus 3 times 3x plus 5. You know,
So for number 10, that means you'd put,
yeah, I was doing number 7 as if it said f of g instead of f times g. In other words, there's not that big a difference between that dot there and this dot here, but I didn't notice it. I just assumed it was a composite function question, and it isn't. Okay?
but so if it said g of f, you just put f into the g equation.
Yeah, exactly. In other words, this note right below this on number 10 is exactly right. G of f of x is written G of f of x. And then it's written G of, well, what is f of x? F of x is x cubed minus 5x, right?
Yeah.
So now, to solve for this, I go to the G equation. Wherever I see an x, I substitute x cubed minus 5x. So that's not that hard to do. It's 3 times x cubed minus 5x plus 3. And that does simplify. Notice that that now becomes 3x cubed minus 15x plus 3. So that would be the answer for 10. And you've got it written pretty close here. Are these your notes or the teacher's notes or notes from the board? Or these are your notes?
No, those are my teachers.
Okay. Well, she's giving you a good process here. In other words, first she writes it as g of f of x, and then she writes it as g of x cubed minus 5, and then she writes it as 3 times x cubed minus 5 plus 3.
And now that there's notation to the right of the find thing, like that equals x, does that mean you have to solve for x?
Where are you talking about?
Like next to the g of f, there's like x in parentheses. Does that mean you solve for x?
No, you're solving for g of f of x.
No, I mean after, to the right of where it says that, it says x.
Right there?
Yeah.
That's just notation. That is g of f of x, which can
But then,
also be written this way.
but then on like number 12 or 13, when there's 6 in those parentheses or 7, that means you solve, like, plug in 7 for the variable.
Right. Let's do number 12 real quick. Okay. First of all, we're going to subtract the two functions, right?
Yeah.
So we have 3n minus 2, and we're going to subtract 3n plus 1. What's that give you?
It crosses out the ends.
Okay.
And then minus 3.
Okay. So that's what g minus f is. Okay. Now, typically, we would have an n still in here, right?
Yeah.
Well, if I had an n, then for n, I would substitute 7. But this is kind of a trick question. They're saying, what is g minus f of 7? Well, when you do g minus f, you get a number. So it doesn't matter what n is. G minus f is minus 3. Let's do 11. I don't like using trick questions to explain stuff because it doesn't help. It hurts. Okay? So let's do 11. First of all, what is 5g equal to?
5 parenthesis n plus 2.
Well, let's distribute it. 5n plus 10. And what is 4h equal to?
That would be 12n minus 20.
Now, add those two together because it says add them. So what do you get?
That would be 17 minus 10.
That's what 5G plus 4H is equal to. Now, if we're going to evaluate that at 9, it means we're going to plug in 9 for n. I could evaluate that at any number I want. But they want us to evaluate it at 9, so I get 17 times 9 minus 10. 17 times 9 is 153, I believe, minus 10 is 143. So there's your answer. Okay. Now, I would have done exactly the same thing on 12, but on 12 it was a trick question because when you subtract the two functions, the n goes away. And you're just left with a number. And if you evaluate that number at various values of n, it stays minus 3. It doesn't change because there's no variable left in g minus f.
Could we just do 16?
Yeah. Okay, here we're dividing f by g. Okay, so let's do it by long division. Minus n squared plus 4n. I'm going to divide by 3n plus 5. How do you do the long division here?
You find out how many times stuff goes into it.
Well, you always start with that term and divide it into that term. That's your beginning spot. How many times?
That doesn't go into that.
How many times does that go into n?
0.
Well, minus 1/3 n times.
Oh, I guess that's true.
Okay, I don't care if I'm using fractions. I'm going to have to use them at some point because it doesn't divide evenly, but it doesn't have to divide evenly. Now the next step is to take that and multiply it by both terms. Well, when I multiply the minus 1/3 n times 3n, I get minus n squared, always gets the same number, right?
Yeah.
Now multiply it by the 5 and you get
5 over negative 5 negative 1/3 n.
Negative 5/3 n. And now subtract. Long division is always subtraction. Synthetic division is adding. Because all synthetic division is removes the variables, changes the sign, and then you can add. But long division is called for here, so we're going to subtract. Well, this gives you 0. What's the other one give you?
4 and 5/3 n.
Yeah, I got to be careful not to write that as an exponent. 4 and 5/3. There we go. And that's your answer. Because they didn't ask us to evaluate it at anything other than n.
But then it's asking us to state the domain.
Okay.
Which would it just be like?
What if I look at the original problem, minus n squared plus 4n divided by 3n plus 5. Domain is always a question of what n cannot be. So what can n not be here?
0.
Well, the denominator cannot be 0. So n cannot be minus 5/3. In other words, if I set up an equation here, I'm going to say 3n plus 5 cannot be 0. That means n cannot be negative 5/3.
Oh, right.
That's the only n that presents any problems. In other words, I don't care if the numerator has 0 in it. The only restriction on my domain is this denominator. at n. Okay, so that's the domain of the function. It was not the domain of g of n, because originally g of n was not dividing into anything. There is no domain restrictions of each of these functions. If you said, what's the domain on 16, I would say all real numbers. But you said, what's the domain on g of n, I would say all real numbers. But once you divide f by g, now all of a sudden g is not allowed to be 0. And so even though we get a final answer that looks like 4 5/3 n, and there doesn't appear to be any domain restrictions on that, there actually are. N cannot be minus 5/3, because that would have caused division by 0 right there. In other words, you look for your domain restrictions wherever they are at any place in the problem. You don't wait until the end. In the end, we're looking at a very simple expression, 4 5/3 n. I would say all real numbers, but you can't do it that way. You have to define your domain in terms of this expression. That expression has f of n being divided by g of n, which means g of n cannot be 0.
Makes sense.
Okay. Let's do one inverse. Or do you know how to do the inverse?
You just switch the variables, right?
Well, there's 2 steps. You switch the variable, and then you solve for y. And it's always better to write these, instead of saying g of x, let's call it y. Because now I can use my rules. My rules say switch the variables and solve for y. I guess I could say switch the variables and solve for g of x, because g of x is the same as y.
Yeah.
If I do that, then I got x equal 5. The math is a little easier if you use y instead of g of x. And now I got to solve that for y. What's the first thing I do?
Wait, which problem is this?
Well, just look at what I got circled here. We're solving that for y. This is 17.
Okay, so then it would be like 5/2y plus 5.
All right, the easier way really here is to get rid of the denominator immediately. Just multiply everything by 2.
Oh.
And then make it simpler. Then you didn't have to deal with turning that into a fraction.
That's true.
Okay, now I'm solving for y. I got to get rid of the 10. And I got to get rid of the 5. So I subtract the 10 and divide by 5, and that gives me y, and that's my inverse. Once you got it solved for y, you could either call that y or you could call it inverse g.
So wait, you switch them and then you solve for the variable that you switched?
2 steps when you're solving for an inverse. Maybe 3. Turn your g of x's in this notation into a y, first of all. Then switch the variables and solve for y. It's exactly what I did. I turned the g of x into y. I switch the variables. I solve for y. That's my inverse function, 2x minus 10 over 5. And I can now call that the inverse, which in that notation is important. That's what that means.
So that just means like basically, so we're going to switch it and then we're going to solve for the thing we just switched?
Yes. Well, when you say the thing we switched, not really. We switched x and y. We're solving for y. We're not solving for the thing we switched, because we switched 2 things.
So you always solve for y even if you switch it?
Yes. In other words, once you've replaced the g of x with y, now there's 2 steps and 2 steps only. Switch y with x, next and then solve for y.
So it doesn't even matter. You're always solving for y.
After you switch x and y, yes.
Okay, that actually makes more sense. I didn't think of it like that.
And let's see, we got 2 minutes here. Let's just set up 18. Okay, so my first step on 18 is going to be to call it y instead of f of x.
Y equals, it would be -4 plus like 5th root of 16.
Okay, so all I've done is rewritten what they have, only I've used y instead of f of x. Now, switch the variables we have.
So it would be x equals that and 16y over 2.
Hold on. The 5th root of 16y over 2. And now solve that for y. And you will have your inverse function.
Okay.
What's the first step?
What?
What's the first step for solving that for y?
Just multiply it by 2, so it's easier.
Now I have 2x equals -4 plus the 5th root of 16y. What next? When you're solving for y and there's a bunch of stuff going on, just start getting rid of the stuff.
You get rid of the root.
Well, let's get rid of the 4 first. It's easier to get rid of the 4. Add 4 to both sides. And now what is the next step?
Can you turn it into a fraction?
Well, I can take each side to the 5th power, right?
Yeah.
In other words, I could write this 16y to the 1/5. Let's just do that so you'll understand what I'm doing. That's the same thing. Now, if I take both sides to the 5th power, I get rid of that fractional exponent, right?
Right.
So now I got 16y is the only thing I have left on the right side. Going to divide both sides by 16. There's my answer. Now, that's equal to y. But it's not equal to f of x. It's equal to f inverse of x. So, in a way, it's a little bit deceiving when the first step is to switch f of x with y, because the y you end up with is not the same y as this y here. The y you end up with is the inverse function. So if I'm going to switch it back into terminology of f of x, I got to call that f inverse of x. Got to call it like that. And so actually, your proper answer is this. You would say f inverse of x equals this quantity.
Yeah.
Okay. It's just easier to solve. It's easier to do the problem if you switch to y immediately. And then when you're done, know that the y you have is actually f inverse of x, not f of x.
Yeah.
All right. Sam, you good to go?
Yeah. Thank you.
Okay, I hope I've been a little helpful. And yeah, I wish I could offer you additional time today, but I am booked solid from like 2:30 to 9 tonight. So good luck on your test tomorrow.
Okay, thank you.
All right, Sam.